Hello and welcome to our introduction section to chapter 5, which is sigma notation. You may or may not have covered this in Math 12. So if you haven't, this is going to be brand new and you might need to spend a little bit more time on this section to understand what's going on. If you did do this in Math 12, then this should be a bit of a review. So first, what is sigma notation? So it uses this big funky E looking thing. And all this means is the sum of, okay? So we have a lower bound and an upper bound. Our lower bound is usually starting at 1, and our upper bound depends on how many terms that we are summing together. If we know how many terms this is, we can have an actual number on top. If we don't know how many terms this is, it's going to say n, okay? So if we had all these terms, we're going to call them A. A1 is your first term, A2 is your second term, A3 is your third term, and AN is your nth term, okay? I is your index of summation, and it won't always be an I here. Sometimes it'll be a K or an A or something like that. We don't ever use an N at the bottom here because N is usually the upper bound notation for when we do not know how many terms there are. AI is your ith term. So A5 would be your fifth term, etc. Okay. So all this big E says is we're going to take this thing here inside of the big E, okay, and we're going to add it together n times, and there's going to probably be something inside of this function that changes, and that's going to be represented by I or whatever letter you have here. So if you've got a K there, then the K inside your function is the thing that changes. If you have any other letters inside your function, inside the big E, that is not something that changes. That is a constant. The only changing thing is going to be whatever this letter is at the bottom, your index. Okay. So let's try one. So we've got this sum here. Okay. We've got 1 plus 2 plus 3 plus 4 plus 5 plus 6. So in my sigma notation, we're going to start at term 1. Term 1 is this. Okay, this one would be term 3. Okay, term 2. And the question is, how many terms are there? Do we know? If we don't know, we're going to put an n at the top. If we do know, we're going to put that number at the top. So think about how many terms do we have here? Hopefully you decided 6. Okay. And then inside the big E, we need to put the function that is represented by each of these terms. Okay. So I is your changing thing. If your terms are changing, something is changing. Okay. So the question is, what is changing here? Well, every time we're going up by 1, but so is our I. Our I is also going up by 1. So all we're summing together here is all of our different I values. So what this would mean is I plus I plus I plus I 6 times. Okay. The first I is 1, the second I is 2, the third I is 3, all the way up to I being 6. So we're doing 1 plus 2 plus 3 all the way up to 6. So our sigma notation is just this. All right, next one. We're starting at term 1. We're ending at term n. We don't know how many terms there are. And the question is, what is changing and what is staying the same? So hopefully we can see that this is changing each time. This is staying the same each time, and this is staying the same each time. So anything that's staying the same should be inside of our function that is inside of our sigma notation. So I should have a 1 over n, I should have brackets, I should have a plus 1, and I should have something squared. The thing that's changing here is what's being squared. In the first example, 1 is being squared. Well, in our first term, I is 1. So this is going to be I. And if I check this, this should make sense. In my second term, that means I should have 2 squared, which I do. In my nth term, I should have n squared, which I do. If this wasn't the case, we might have to have something like I plus 2 all squared, or some sort of change of I before we square it. Now, when I do this, there are a couple properties that we've got below that we can see work for our sigma notation. One says that if you have some constant k inside of your sigma notation, we can take that out and put it in front. Now, we just finished saying that the changing thing here was this I, which means everything else is not changing. Now, I can't take the squared or the plus 1 and put it in front because those aren't constants, but this 1 over n is. I can take this 1 over n out and put it in front and end up with I squared plus 1 inside of my sigma. Now, there's some other different properties here. The other property says that if you have two terms adding or subtracting together, that gives you two separate sigmas. Okay, so if I take my two terms adding together here, this is going to give me two separate sigmas. They still will start at 1 and go to n. And the first one has an I squared inside, and the second one has a 1. Okay, now if I scroll a little farther down, we can see that if we have just a constant inside of our sigma, this is going to be the constant times n. If we think about this, this should make sense. If I had I as 1 to 5 of the number 3, this means you're going to take 3 and you're going to add it together 5 times, which would be 3 times 5, right? Which is what this is. Okay, so if I look at that, that means my second sigma notation should just be 1 times n. Okay, or just n. The first sigma notation, I have an I squared inside. We scroll down a little bit farther, we can see that we actually have what is called closed form for I squared. This means that some mathematician at some point has come up with a formula that works for any I you put in here, any number of terms you have. If I have 5 terms, this is going to be 5 times 5 plus 1 times 2 times 5 plus 1 over 6. Okay. So this one is going to be n times n plus 1 times 2n plus 1 over 6. And let me just, I underestimated how much space I needed here, so let me just fix this. So I end up with n plus 1, 2n plus 1, all over 6. And now I can distribute my 1 over n back in. So I can distribute this into my brackets. When we do that, hopefully we notice that the n's are going to cancel out because I'm going to end up with n times n plus 1 times 2n plus 1 over 6n plus n over n, which is going to give me n plus 1 times 2n plus 1 over 6 plus 1. Now, we usually like to make common denominators. So this is going to be 2n squared plus n plus 2n plus 1 plus 6 all over 6. So all I did here was common denominators. And then on the top, we can just fix this up a little bit. So we end up with 2n squared plus 3n plus 7 all over 6. This is called closed form. So if a question asks you to write something in closed form, what it's asking you to do is to break apart the sigma notation and use these different properties and formulas to evaluate each sigma notation. And if you do not know how many terms there are, meaning you have an n at the top of your big E, you should have an n in your answer. Okay? If you know what that number is, then you would plug it in at this point. So if I told you there were 5 terms, that means n is 5, and I can plug 5 in here for my n. If you just want sigma notation, this here is sigma notation. Okay? These use the properties below to write something in closed form. All right. Let's try one more. You are going to get very comfortable seeing this one. It's going to come up in this chapter. Okay. So here we look at what is the same and what is changing. So we've got our sigma notation. We're starting at term 1. We don't know how many terms there are. We're ending at term n. The question is, what is inside? Well, I've got an f of everywhere, and I've got a delta x everywhere, so those are going to stay the same. And I see that I've got an x inside my f, but the subscript is changing. The first term, it's 1, then it's a 2, then it's an n. So this subscript is going to be our I. Again, you will see this one lots. Those of you taking an AP Calculus exam, they love to bring this up on the AP Calculus exam. Make sure you know this, okay? And we'll do this more in chapter 5. All right, let's try one more question. This one's a tough one. Okay. We want to express this in closed form. We don't have an I, now we have a K. You can go ahead and change that to an I if you don't like seeing it as a K, that's fine. Okay. And the question is, what's changing and what's staying the same? If we have any constants, can we pull those out? If we have anything adding or subtracting, we can break our sigma up into smaller pieces. So here, we don't have anything adding or subtracting, so we're not going to be able to use that second summation property. But we do have a constant. The thing that's changing is our k, which means this n is a constant, and I can bring that out in front and be left with k squared. Now, normally we have this lovely formula that says if we're going from 1 to n of I squared, then we have n times n plus 1 times 2n plus 1 all over 6. The problem here is that we are not going up to n. We are going up to n minus 1. So instead of having n, everywhere we have an n should be an n minus 1. If this was a 7, everywhere we have an n, we'd put a 7. Okay? Since it's an n minus 1, everywhere we have an n, we need to put an n minus 1. Okay, so we're going to have n minus 1 times n minus 1 plus 1 times 2 times n minus 1 plus 1 all over 6. And now we simplify. So we're going to have 1 over n times n minus 1. In our next set of brackets, these cancel out. And in our third set of brackets, we need to expand. So we're going to end up times n times 2n minus 2 plus 1 all over 6. Hopefully we notice next we can cancel these n's out. And then we're going to end up with n minus 1 on the top times 2n minus 1 all over 6. The 2n minus 1 comes from simplifying this. That's it. That's closed form. We do not need to expand. We are done. The only reason we expanded on the previous one is because of this one here that we wanted to combine together to be one giant fraction. And then basically if we said, okay, you have an infinite number of terms, you know, what is this expressed as in closed form? Or you have 7 terms, you put a 7 in for your n. And that is all for this section.